Okay, let's talk a little bit about ductile and brittle materials. When you're designing structures, there's lots and lots of different materials you can use, and there's lots of different ways to think about them. One of the most fundamental distinctions we make is whether a material is ductile or brittle. And a ductile material is one that bends before it breaks, and a brittle one is a material that doesn't. It's fairly simple. I've got a couple examples here. If you look at this thing right here, this is a piece of just brass rod. This is actually brazing rod, but it's a soft brass. If I grab it like this, and I can bend it, as long as I don't bend too far, it'll go back to its original shape. It hasn't permanently bent. Okay. If I do this, now it's permanently deformed. When I let go, it didn't go back to its original shape. This is a ductile material. It's bent, and this is called plastic deformation. Okay. This bent without breaking. Now, I already broke this because this is my second attempt at this little clip. This is a piece of chalk. Now, chalk is a very brittle material. You can see I broke it right there. Broke into two pieces. You put it back together, right? If I can get this together exactly the right way, there we go. And I press so that you can't really see the crack in it. There's no evidence that it's actually broken. It didn't bend at all before it broke. Okay? It broke without bending at all. That makes this a brittle material. Now we can talk about it in kind of imprecise terms like this. There's a much more precise way to describe ductile and brittle materials, and that's to use a stress-strain curve. So let's draw one of those.